All right, folks, this is Chapter 8, Section 8-3, and this is recording number 1. All right, let's see where we are. We're in the hypothesis testing Chapter 8, and remember there's a distinction between 8 and 9, which I've already mentioned a couple times. 8.1 is just an introduction. 8.2 is the z-test for a mean. That's if we know the population standard deviation. So we just finished that video. Now we're going to talk about 8.3. This is the test for when we do not know the standard deviation for the population. Okay, so let's take a look at that. Now it's going to be very similar to what we've already done. So this will be a much shorter video. It's a much shorter chapter. It's going to be very similar. The concepts are the same. The only difference is instead of using the Z distribution, we're going to use the T distribution. Now, we already talked about the T distribution when we were dealing with confidence intervals. So remember, in confidence intervals, we had a situation where we would try to estimate the intervals, and sometimes if we knew the population standard deviation, we would use a certain test. If we did not know, we'd use a different test. Well, we're doing exactly the same thing. The z-test if we know it, the t-test if we don't know it. Okay, so here we go. When the population standard deviation is unknown, the z-test is not typically used. It's a different test. It's called the t-test. One of the requirements, however, is that the variable itself, the variable that you're dealing with, should be approximately normal, okay? And then here's some similarities between the T distribution and the Z, or the normal distribution, okay? If I really wanted to be precise, which I always do, I shouldn't call this the Z distribution. I should be very careful about that, and so should you. A normal distribution is a normal distribution. The Z distribution is the standard normal distribution. That's the one that has a mean of 0 and a standard deviation of 1. So there is a distinction. We have to be a little more cautious about that, okay? Oh, okay. But here he's talking about the T distribution is similar to the standard normal distribution. So he is talking about the standard normal distribution. That's the Z distribution. Okay, so that's what we're talking about here. So I'm going to let you read that yourself in your book. Okay, it's exactly the same as what we talked about before in the section dealing with confidence intervals. The t-test, and it's going to look almost exactly the same. It's a statistical test for the mean of a population. So we're comparing a sample that we draw out. We're going to compare that to the population mean. We're going to compare the x-bar to the population mean. And it is used when the population is normal, okay? It's normally distributed, or it is at least approximately normally distributed, and sigma is unknown. Okay, so the formula for the test is this. It looks very similar, does it not? It's x bar take away mu. That's the how surprised are you? That's how the difference in the numerator. It's how surprised are you by this x bar? How much of a difference does it have from the mu? And then on the bottom is our yardstick. But instead of using sigma over the square root of n, we have s over the square root of n. And s, of course, is the sample standard deviation. And then the degrees of freedom is exactly as before. It's n minus 1. It's 1 less than the sample size. So it's a family of curves, as you may recall. Okay. All right. So what he's saying here is, okay, we don't know the standard deviation sigma, so what we're going to use is we're going to use s instead, and we're going to use a different distribution here, okay? All right, so the critical values, we've already had some experience using those. They're in the table F in Appendix A, okay? And we showed you before how to do that. For a one-tailed test, you find the alpha level by looking at the top row, and find the degrees of freedom by looking down the left-hand column, okay? All right, so I'm going to let you read that. It's very similar to what we did before in the confidence interval situation. Okay, as the degrees of freedom get larger, in other words, when you say a degree of freedom gets larger, what you're saying is the sample size gets larger. So as the sample size gets larger, the critical values approach the z-values. It starts to look more and more like a normal distribution. Excuse me, it starts to look more and more like a standard normal distribution. Okay, and that's why. Okay, so I'll let you read this. As I said, he's talking about how to use different values. This paragraph right here is a little bit confusing. He says, as the degrees of freedom get larger, the critical values approach the z-values. Hence, the bottom values, in other words, the large sample size. So for a large degree of freedom, therefore a large sample size, you get the same numbers. The z-values and the t-values, the actual numbers are the same for the corresponding probabilities that you're looking for. In other words, if you want to have a 10% beta, it's going to be the same number. All right, and hopefully we'll see an example or two of that. Okay, so find the critical t-value for alpha is equal to 0.05. Degree of freedom of 16 has to be a right-tailed t-test. Okay, so that should be doable for us. Okay, now I'm going to try to do this, but the best way for you to handle this yourself is you should have your book out and be kind of following along here. It's really hard for me to bounce back and forth. I'll do my best. Okay, so we want alpha is equal to 0.05, and it's a right-tailed test. So up here you have one-tailed tests and two-tailed tests. So we'll talk about a two-tailed test in just a second. But a one-tailed test, here it is, okay? And it's supposed to be alpha is 0.05. Degree of freedom is 16. So here's the degree of freedom is 16. So this gives you the column, this gives you the row, and it's 1.746. So now let me bounce over to the textbook, okay, and see if we can come up with the same thing. Now, you see the cartoon down at the bottom of your textbook gives you the area, okay. Now remember, the t distribution is symmetric about the mean, so it facilitates things, to say the least. Okay. All right. So now, when we're talking about the testing, okay, we want to have a one-tailed test. Alpha being what we just said was alpha is 0.05. Okay. So 0.05, one tail, there it is. That's the column. So this whole column here, and we want the degree of freedom to be 16. So we got to come back up here to 16, and here it is, 1.746, which is exactly what the book got. Now this might be a little hard to read on your screen, but that's the best I can do here. Okay. So here's 16, and here's the 0.05. Okay. So whereas before, when we were using the t-distribution, we were using these tables, we were talking about confidence intervals, and so we had 80%, 90%, 95%, and so forth. We were using these columns, or these rows up here, to find the appropriate columns. Now we're using these two rows, the one-tailed test and the two-tailed test. All right, and we'll see how that works here in a moment. Oh boy, let me stop this. Okay, so far all we've done is practice finding the critical values. We haven't practiced, how do we use these critical values? We're going to see that here ASAP. All right, so now critical t-value for alpha is equal to 0.01, degree of freedom of 24, with a left-tailed t-test. Okay, so again, we do exactly the same thing. We're going to find the degree of freedom of 24 down the column. We're going to find the critical value in the 0.01 column in the row that's labeled one tail. Find 24 in the left column for the degree of freedoms, and then it's going to be a negative number because the test is left-tailed. Now let's see if we can make sense out of that. It's hard to bounce back and forth, so what I'm going to do is read it out of my book as I'm going along here. Okay, so what we want is degree of freedom of 24. That seems to be the easiest thing to find first. There it is. 24, this row right here. The other thing we want is alpha is being 0.01. So here it is, 0.01. Oops, that's the two-tailed test. Here it is. 0.01, okay, so it's one tail test, 0.01, and then we got to go down the rows here, and we want the degree of freedom of 24. So this is so hard to do on the screen, but I'm going to do my best here. I think it's right there, 2.492. So I claim that that's 2.492, and that's what the book says, 2.492. However, we have to worry about the sign, the positive or negative sign. It's a left-tailed test, so they can't have two tables. I mean, it just would be a waste of space to have two different tables. So they give you this number. They tell you that it's 2.492, but you need to remember and keep in mind that that's this number. That's the positive guy over here. Okay? If you want this guy, if you want a left-tailed test, well, you pick the opposite sign. You make it zero, or excuse me, you make it negative 2.492 because it's a left-tailed test, so it's going to be over there. So that's how you do these. Now, for a two-tailed test, it's going to be kind of the same idea. We're going to use this chart. So that's the next one. Critical values, alpha is equal to 10, degree of freedom of 18. It's a two-tailed test, okay? All right, I'll let you read that, but let's just see if we can do it let's see if I can do it on my own without reading the instructions here. The hardest part is just bouncing between the screens here. Okay, so we want a two-tailed test, degree of freedom is 18. Okay, so there it is, 18. It goes right across here, but now we got to find out what do we need for the columns. So they just told me it was a two-tailed test. They told me it was alpha of 10, so alpha of 10 right there, alpha of 10, two-tailed test, and then I go down the rows. This is the appropriate column. I go down the rows to come on down right there, 1.734. That's what I claim the appropriate number is. Let's see if I'm right. 1.734. But wait, there's more. It's 1.734 plus and minus. Why is that? Let's take a look. It's a two-tailed test, so I need this guy and I need this guy. Okay, and the problem was given to us as an alpha of a total alpha of 0.10. So that's the 10%. That's my error budget. So if it's a two-tailed test, half of the error budget is over on the right-hand side, half of the error budget is on the left-hand side, so it's 5% on each side. That's why you'll see right here at the bottom of your page, which in your book, which doggone it, I hope you're looking at it. At the bottom of your page, it'll be alpha over 2, okay? Okay, so now we know how to find these. I did a couple of the examples for you. I'll leave the other examples for you. So now that we know how to find the critical values using this table, we need to learn how to test hypotheses. In order to test hypotheses regarding the population mean, when the standard deviation is unknown, here's what we have to do. These are the assumptions that you have to verify, and we'll see that in the next video.